For question 1, we're trying to figure out if it's synthetic or analytical geometry. For 1A, we notice it's analytical because it's written on graph paper. For part B, the reason we know it's synthetic is because there is no graph paper. For question 2, we're trying to figure out how many people there are. We know there are 4 suits. Every person gets 3 different suits. Any suit grouping has exactly one person who likes all 3. So, I made a list. I have there first spades, clubs, hearts, spades, clubs, diamonds, spades, hearts, diamonds, and clubs, hearts, diamonds. Those are all 4 different ways you can organize it, which means there are only 4 different people. For question 3, we have to do some drawing. First, I draw plane B, which I draw a parallelogram and I put a big bold B on it. Line N is described as non-coplanar ST. That means that it goes through the plane and is not in the plane. So I draw a line, I label it N. We are then told that points P, Q, and R are coplanar. That means they are drawn inside the plane. And we are told that S is non-coplanar. S is also on line N, so I just had to put it on the line, but not inside the plane. It doesn't tell us where T has to be, so I put T in the plane, but T could have been anywhere on that line. Problem 4 just says to name the following. Part A says the 3 points. There are dots that are labeled M, A, and D. Part B says find the intersection of the 2 drawn lines. Well, the lines cross at point A. Part C wants us to label the plane, so we write a little parallelogram and then we label 3 non-collinear points, M, A, and D, the only points actually in the plane. Part C, it asks for 3 lines. Well, the easy ones are MA and DA, but one that's not shown is MD because we can draw a line through any 2 points. Make sure to put the line symbol above each one of those pairs of letters. Problem 5 should be easy. You have 2 line segments over there, with one with the distance of 1.5 inches, the other one with 3.75 inches. And basically, it's just reading. AC is the whole distance, which is 1.5 plus 3.75, which is 5.25 inches. AB is the first segment, 1.5 inches. BC is 3.75 inches. D, E, and F are those letters swapped, so you just have to figure out the right position to place them. Problem 6 is similar to problem 5, except for there is a missing distance, which is YZ. XZ is the full distance, so 9 and 5/7 meters. XY is also the distance given, which is 3 and 2/7 meters. And C is the missing distance. So I'm going to take the full distance, subtract the small distance, and that gives me the remaining distance, which is 6 and 3/7 meters. Remember on these problems that you should label units. Problem 7, a little bit harder. First, we have to set up the picture since it wasn't given to us. So we have a line segment CDE. CD is 9x, DE is 5x, and CE is 6x plus 2. Then we know that the 2 smaller segments equal the bigger segment. So we have 9x plus 5x equals 6x plus 20. Combine like terms, that's where we get the 14x from. Then we move the 6x over to the left-hand side by subtracting 6x from both sides, which gives us 8x equals 20. Divide by 8, and that gives us x equals 2.5. So we have the answer to 7a. CD is 9 times 2.5, which is 22.5. C is DE, which is 5 times 2.5, which is 12.5. And CE we find out by taking 22.5 and adding 12.5 to it to get 35. For problem 8, we need to find distances. Since distances are always positive, it doesn't matter which 2 numbers we subtract. I always try to subtract the bigger number from the smaller number so that it is an easier process. For AD, we're taking 11 minus 3, which is 8. For part B, we're doing BE, which is 14 minus 5, which is 9. For DA, it's actually just problem A again. I just switched the 2 letters. And for D, it is CA, which is 8 minus 3, which is 5. For problem number 9, we're going to have to use the distance formula. The one I'm choosing to use is a squared plus b squared. For 9a, we're going to look at the distance from 12 to negative 3, which is 12 minus negative 3, which is 15. But the second two numbers, negative 10, are the same number. So technically, this is just the number line. So the distance is 15 for the exact answer. And rounding it to the nearest tenth is 15. For part B, we're going to do the same thing, but 8 minus 8 is 0, and 13 minus 13 is 0. So the distance are 0 and 0. Part C, we have 10 and negative 2. So 10 minus negative 2 is 12. And 5 minus negative 3 is 8. So we have 12 squared plus 8 squared, which is 144 plus 64. When we add them together, we get 208. So the exact answer is the square root of 208. Plug that into a calculator, and I get the nearest tenth distance is 14.4. For problem 10, we need to worry about fractional distances, which means we need to know three things: how far it is, the fractional distance, and which direction to move it. So from A to C is 9 minus 14, which is 15. The fractional distance for part A is 3/5, so 15 times 3/5 is 45 over 5, which is equal to 9. Since we are going from A to C, we're going to add 9 to 4, which gives us an answer of 13. For part B, it is a ratio, 4.1. So it's going to be 15 times 4 divided by 4 plus 1, the 4 and the 1 from the dots. That is 60 over 5, which is 12. But this time we're going from C to A. So since we're going backwards, we're going to take 19 and subtract 12, which is 7. Problem 11 is problem 10, but we do it twice. First, we're going to start with the x's. We're going to find the distance from 8 to 1, which is 8 minus 1, which is 7. Then we're going to take a third of that distance, which is 7/3. 1 plus 7/3 is 3.3. The reason we are adding is because the 1 to 8 is in a positive direction. For the y's, we're going to go from negative 2 to negative 8, which is a distance of 6. Then we're going to take that 6, and we're going to take a third of that, which is 6 over 3. Plug negative 2 minus 6 over 3 into a calculator, and we get negative 4. Why are we subtracting this time? Because going from negative 2 to negative 8 is in a negative direction. So we're going to take those 2 points and put them back into xy coordinates, which is 3.3 comma negative 4. Problem number 12 is the midpoint formula. And to be fair, the midpoint formula is pretty easy. You add the two numbers together and you divide by 2. So A is at negative 1, E is at 6, negative 1 plus 6 is 5, half of 5 is 2.5. Problem 13 is problem 12, but twice. First, we're going to start with the x's. 25 plus 10 is 35. Half of 35 is 17.5. The y's are 24 and 1. 24 plus 1 is 25. 25 divided by 2 is 12.5. Put the x first, the y second, and we are done with that midpoint formula. For problem number 14, we're just using the fact that we know that something is a midpoint. AB is 2y plus 10. BC is 4y minus 2. They are equal to each other because B is the midpoint. That means that 2y plus 10 equals 4y minus 2. We move the 2y over to the other side, so we get 10 equals 2y minus 2. We then move the 2 to the other side, trying to get y by itself. We get 12 equals 2y. Divide both sides by 2, we get y equals 6. Some of you will sadly end there, not realizing that the question was find the distance of AC. So I plug 6 into 2y plus 10. I get 12 plus 10, which is 22, which gives me half the line. Well, if that's half the line, then the full line would be 22 plus 22, which is 44. And that is the end.